Okay, so in this video, we're going to be talking about a concept called as project crashing, and this is a concept of management science. And the basic idea of project crashing is that if you increase the number of resources that you're using, you will be dropping the overall duration of the project. Okay, so let's take an example to understand this better. Let's say you're constructing a building, and it's taking you 6 months to complete the construction of the building with 2 laborers as your resource. So what if you wanted to finish the building in 3 months? If you wanted to finish the building in 3 months, the answer is simple. You just need to double your resources, and instead of finishing the building in 6 months, you'll be able to finish the building in 3 months. So if you're if you're constructing a building with 2 laborers in 6 months, you can finish that building with 4 laborers in 3 months. That's the very basic idea of what project crashing is all about. Simply increase your resources in order to decrease the overall duration of the project creation. Okay, so what is the concept of direct cost? So we have two things which is very important in order to understand project crashing, and that is the direct costs and the indirect costs that go into the project. So direct costs are nothing but the initial investments that you'll have to make into the project, irrespective of whether or not the project will actually be finished in 6 months or 3 months or whatever duration you have allotted to it. So let's say that you're constructing a building. Since that example we have taken, we'll go ahead and continue with that example. So let's say you're constructing a building. What are going to be the initial costs that you're going to have to invest into the building? So the first thing is, of course, going to be the initial cost of buying the land. Then there is going to be the costs such as the raw materials that you're going to require, such as the cement and the brick and whatever else it takes. And all these initial costs are going to have to be put in very early on into the project. So if you take a bar chart and try to understand this, and if you take the costs on the y-axis and the duration on the x-axis, you're going to realize that as the project progresses, the direct costs will drop overall. But initially, when the project is just getting started, if this is the start point and if this is the end point, if the project is just getting started, the initial costs of the project are going to be very, very high. The direct costs of the project are going to be very, very high. But however, as the project goes on, the direct costs are going to keep steadily dropping until they reach to the null point. Now, what are indirect costs? Indirect costs are the costs that you never see coming, but they will keep occurring into the project. So for example, you started off with the project with 2 laborers. However, 1 laborer got into an accident and he couldn't show up. So you had to hire another laborer in his place. Now that's an indirect cost that you did not see coming, but it was added to you nonetheless, right? Let's say that you had bought 2 bags of cement in order to finish the project, but it actually took you 3 bags to complete instead of 2 bags. So that one extra, the cost of that one additional extra bag is going to be an indirect cost. It's a cost that you never saw coming, but it occurred nonetheless. So as you can see in the bar chart, initially when you start off with the project, the indirect costs are going to be very low. But as you progress with the project, the indirect costs are going to keep getting higher and higher until you finally reach the end point of your project. So the more the duration, the higher the indirect costs will get. However, the more the duration, the lesser the direct costs will get into the project. And this is the basic idea of project crashing. Now let's go ahead and see an example in order to understand project crashing better. Okay, so here is an example question that has been asked for project crashing. So let's just go ahead and read this. From the activity details given below, determine the optimal project duration and the optimal project cost. And the indirect cost is 75 rupees per day. Okay, so if you have a project which is going to last, let's say 100 days, every single day the indirect cost is going to be at least 75 rupees, and that has been given in the question itself. And over here a table has been given to us, and this is the table in which you have activities, the normal time, the normal cost, the crash time, and the crash cost given. And the activities are basically the sequence of events that are going to occur in the course of building or constructing or completing your project. Okay, and the normal time is going to be the approximate time that it's going to take for us to move from one activity to another. Okay, so from one event to another. So this right here is event number 1, this right here is event number 2. In order for us to get from event number 1 to event number 2 in this activity, the normal time is going to be 8 days, The normal cost for this activity to be accomplished is going to be 100 rupees. The crash time is going to be 6 days. So if you wanted to reduce the time by increasing the number of resources, you're going to be creating a crash time which is 6 days. And then you have the crash cost, which is 200 rupees. Okay, since you are increasing the resources, you'll also be spending more money into the project. So instead of the normal cost of 100 rupees, you're going to be spending 200 rupees. And similarly for activity 1 to 3 and 2 to 4 and 2 to 5 and 3 to 4, we have so and so details given. And now using these details, what we are going to be doing is we're going to be figuring out two things. The first thing is the optimal project duration, and the second thing is the optimal project cost. Okay, so there are now three things that you have to understand in project crashing. The first is step 1, and then you have step 2, and then you have step 3. Okay, so it's a 3-step process, and we're going to be going through it one after the other. Okay, and it's also an iterative process that you have to keep in mind. It's an iterative process, which means there are going to be multiple iterations in this project. So the first thing that we are going to be doing in step 1 is we are going to be figuring out the critical path by creating a network diagram. Okay, analyzing all the different paths there are. Then we are also going to be analyzing the project duration and the total cost of the project. These are the three things that you have to do in step 1. First thing is figure out the critical path. Second is the project duration. Third is the total cost. Okay, so using the activities given right here, we are going to be creating a simple network diagram, right? So for activity 1 to 2, we have created a network diagram 1 to 2, and the normal time for accomplishing this activity has been given as 8. So what we are going to be doing is we're going to be writing an 8 over here. Okay, and you can notice that there are double lines here, whereas there is a single line here. I'll be explaining that to you in a minute, so don't get confused. So then we have 1 to 2, 2 to 5, 1 to 3, 3 to 4, 2 to 4, and 4 to 5. All the activities that have been given here have been written here, and the normal time for each activity's completion has been denoted. Now, since this is the first initial node or the first initial event, and 5 right here is the final node or the final event in our network diagram, we are going to be analyzing the number of paths available for us to go from node 1 to from initial node to the last node. So one path right here is 1 to 2 and 2 to 5, right? From path 1, from node 1 to node 2, and from node 2 to node 5, we can go like this. So that one path has been denoted right here. Another path is node 1 to 2, 2 to 4, and 4 to 5. So that has also been denoted over here. Then we also have node 1 to 3, 3 to 4, and 4 to 5. That has also been denoted right here. Okay, so in order to find out the critical path, we have to find out the longest possible path that it can take for us to reach to our goal. Okay, so in order to go from node 1 to 2 and 2 to 5, we have the durations 8 and 10. Let's just go ahead and add them, and then we have 18 days using the path 1 to 2 and 2 to 5. Similarly, we have 8 plus 2 plus 3, which is going to be 13 days, and we have 4 plus 5 plus 3, which is going to be 12 days. So as you can see, the longest route is of 18 days, and it is using the nodes 1 to 2 and 2 to 5. And this right here is going to be our critical path. And the double lines that you see right here from 1 to 2 and 2 to 5 have been drawn to denote in this network diagram that this is our critical path that we are going to be using. So the first problem is solved. We have figured out the critical path for this step, and that is 1 to 2 and 2 to 5. And the duration that we are going to take in order to get to our goal is going to be 18 days, which is the critical path. The total cost is nothing but the summation of all the normal costs that have been given to us in this table. So right here you have all the normal costs, right? 100 rupees, 150 rupees, 50 rupees, 100, 180 rupees. We are simply going to add them all together, and that is going to be our total cost. And this is the end of our step 1. Now we'll move on to step 2. So in step 2, we are going to be finding out something known as cost slope. Now, what is a cost slope? Now, since we are going to be crashing the project, which means basically if it's taking us 10 weeks to complete the project, we are going to try to finish this project in 8 weeks. We are going to try to reduce the overall duration by increasing the number of resources. Now, if you increase the number of resources, what's going to happen is you're going to be spending more money than you were spending initially into the project. And in order to find out how much exactly that money is, we are going to be finding out the incremental cost due to crashing. So if we crash this activity, how much money is actually going to increase? How much more money are we going to spend? We are going to figure that out. And in order to figure that out, we are going to be using the cost slope. And the cost slope is a very simple formula. It is nothing but the crash cost minus the normal cost of the activity divided by the normal time and the crash time of the activity. Okay, so the crash cost minus the normal cost divided by normal time minus the crash time of each and every single activity. Let's go ahead and figure it out. So we have activity 1 to 2, 1 to 3, 2 to 4, 2 to 5, 3 to 4, and 4 to 5. And for each and every single activity right here, we are going to be applying this formula, and using the details given to us in this table, we are going to be figuring out the results. So once again, crash cost minus normal cost divided by normal time minus crash time. So for activity 1 to 2, we have the crash cost 200 rupees minus the normal cost 100 rupees whole divided by the normal time, which is 8 days, minus the crash time, which is 6 days. 200 minus 100 divided by 8 minus 6, that's 100 by 2, which is 50. Similarly, for each and every single activity, we are going to be applying the formula and getting the cost slope for each and every single activity. And this right here is your step 2. Step 3 is going to be our final step. Now, even though step 3 is our final step, it is also going to be our longest step. And the reason for that is because you're going to have to do step 3 in iterations, right? This is going to be an iterative process. You're going to repeat the process a couple of times in order to reach your final goal, which is to reach the optimum duration and the optimum crash cost, right? So in step 3, the first thing that we're going to be doing is we are going to be finding out what is known as our critical activities. So since we have already figured out our critical path, which was 1 to 2 and 2 to 5, we are going to be breaking this down into critical activities. So we have two critical activities here. We have 1 to 2 and we have 2 to 5. Okay, and these activities have been denoted right here. Now, the critical activities and their cost slopes are going to be written in a table in order to understand better. The first activity is 1 to 2 and the cost slope that we figured out for this was 50. Similarly, for activity 2 to 5, we had figured out the cost slope, which was 60. And so that has been noted here. Okay, so the activity that we are going to crash, which means the duration of the activity that we are going to decrease, is going to be the activity which has the least amount of cost slope. Okay, so the critical activity with the least cost slope here is 1 to 2 because it is 50, right? And another thing that we have to keep in mind is that the next longest path has the duration 13, which is 5 less than the critical path. 5 units is the maximum crash limit for the activity 1 to 2. Did you understand this? I'm pretty sure you didn't. So let me go ahead and explain what I'm talking about. So as you have seen here, we have 3 possible paths to reach our final goal, right? The first part was 18, the other part was the duration of 13 days, and the other part was the duration of 12 days. So as you can see, the next longest duration is 13 after the critical path, right? And the difference between the two is 5 units. Right? So now whatever activity it is that you're going to be crashing, you have to make sure that that activity does not decrease by more than 5 days or more than 5 weeks or more than 5 months, whatever unit it is you're using. So it shouldn't exceed more than 5 units. Okay, and that is what you have to keep in mind. And that's all that it is trying to say. No matter how much you crash, make sure it is less than 5, because the next longest path is 13. Okay, after the critical path 18, the next longest path is 13. So you only have 5 units available in which you can reduce. So the crash activity that we're going to be reducing is going to be 1 to 2. Okay, and the formula for crashing the activity is nothing but normal time minus the crash time. Okay, so for activity 1 to 2, the normal time is 8 and the crash time is 6. So we're going to be subtracting 8 from 6. Okay, normal time minus the crash time, 8 minus 6, and that's 2. So we will be crashing 1 to 2, activity 1 to 2 by 2 units, and that is going to be our first iteration. So in first iteration, the activity 1 to 2 is going to be reduced by 2 units. So as you can see, I have cut the 8 right here and I have marked it with 6, right? I have subtracted 8 with 2 and I have reduced the overall time by 2 days. Or 2 units in this case. Okay, so in iteration 1, we have to figure out 2 things. The first thing is going to be the total cost. Now, as you have noticed before, we have figured out the total cost in our step 1, right? We are simply going to be repeating the same step, but the formula for the total cost is going to slightly change. So the first thing that we are going to keep in mind is the direct cost. The second thing that we are going to be adding in this is the cost due to crashing, and the third is the indirect cost. Now the indirect cost has been given to us in the question itself, right? 75 rupees per day. That's our indirect cost. The direct cost of this project is nothing but the total cost that we figured out in step 1, which is nothing but 580 rupees. Okay. Now what is cost due to crashing? Cost due to crashing is nothing but the number of days multiplied with the cost slope of that activity. Okay, so the number of days that we have crashed, as you can see, we have crashed 2 days, so that's going to be 2 into the cost slope of that activity that we were crashing. So the cost slope of 1 to 2 was nothing but 50, so 2 into 50. Okay, so the total cost is going to be nothing but the direct cost plus the cost due to the crashing plus the indirect cost. So that's 580 rupees plus 2 into 50 plus 75, which gives us 755 rupees. And that is our final total cost. Now once again we are going to look at the various paths. Now again the duration of those paths is going to change. Since we have reduced 1 to 2 and 2 to 5 by we have reduced 1 to 2 by 2 units. Now we are going to be changing the duration of the critical path, right? The critical path 1 to 2 and 2 to 5 is now going to be 6 plus 10 instead of 8 plus 10, which is going to yield us 16. And now the next longest is 12, and so the difference between the two is going to be 4. And that's how much, that's the maximum amount of duration, that's the maximum amount of duration that you can subtract. Okay, and you cannot go beyond 4 units. That's what you have to keep in mind. And that's what the point right here says. Since the difference between the critical path and the next longest path is 4 units is the maximum crash limit for the next activity. And for the next activity, we are going to start with the second iteration. Now the second iteration is going to be about activity 2 to 5. The reason why we are using activity 2 to 5 is because activity 1 to 2 has reached its maximum limit. We have removed 2 units and now it has reached its maximum limit. We cannot reduce it any further. So what is the other activity that we had in our critical activities? 1 to 2 is over. We have 2 to 5 left. So in the second iteration, we're going to focus on 2 to 5. Once again, we're going to apply the formula normal time minus crash time. Okay, and for activity 2 to 5, it is 10 minus 5, as you can see right here. Activity 2 to 5, normal time is 10, crash time is 5, so 10 minus 5, which is going to be equal to 5. But we already know that we cannot go beyond 4 units, and right now the crash, the activity crashing is at 5. So we are going to have to make sure that we don't do this, we don't reduce the activity by 5 units. We have to make sure that we only go 4 units. And that's what this point right here says. But it is possible only to crash by 4 units. So we'll be crashing activity 2 to 5 by 4 units in the second iteration. Okay, so activity 2 to 5 in the second iteration has been reduced. I've cut the 10 and I've written 6 right here because I've reduced 4 units. Okay, and once again we are going to be calculating the total cost in the second iteration. So the total cost formula is nothing but the direct cost plus the cost due to crashing plus the indirect cost. We have the formula right here: direct cost plus cost due to crashing plus the indirect cost. So what is the direct cost? 580 rupees plus the cost due to crashing. So in the first iteration, the cost due to crashing was 2 into 50. We're going to keep that right here. We are also going to add the cost into crashing of this iteration right here, which is 4 into 60. And how do we get this? We are reducing 4 units. So that is 4 into the cost slope of that activity. And the cost slope of that activity is 60. So 580 plus 2 into 50 plus 4 into 60 plus 75, which is our indirect cost. We are going to reach to 995 rupees. And this is our total cost for the second activity. And once again, we're going to analyze the various parts now, right? So since we have reduced 2 to 5 by 4 units, we are going to have new paths. We are going to have new durations for the paths. So 1 to 2 and 2 to 5 is now going to be 6 plus 6, which is 12. And 1 to 4 and 1 to 2 and 2 to 4 and 4 to 5 is going to be 11 units. 1 to 3 and 3 to 4 and 4 to 5 is going to be 12 units. Now, as you can see, for the path 1 to 2 and 2 to 5 and 1 to 3 and 3 to 4 and 4 to 5, you have the same durations, which means now our critical paths are 2 instead of 1. We have 2 critical paths, 1 to 2 and 2 to 5 and 1 to 3, 3 to 4 and 4 to 5. And the critical activities similarly for 1 to 2 and 2 to 5 are going to be 1 to 2, 2 to 5, and for this it's going to be 1 to 3, 3 to 4 and 4 to 5. Now there is really no need to get confused here, and the reason for that is because since we have already figured out since we've already crashed 1 to 2 and 2 to 5 almost by 6 units now, it's not going to be very hard to complete this problem. The only thing that you have to keep in mind now is that both the critical paths are now going to be reduced simultaneously together. Okay, so you cannot just reduce one activity in one path. You're going to have to reduce 2 activities, right? One activity from each path. Okay, that's what you have to keep in mind. First thing is first, let's go ahead and figure out the activity in the cost slope, just as we had done before. As you can see in the step right here, the first thing that we had done was we had divided the critical path into critical activities and we had written the cost slopes down. So similarly, for the new critical path right here, 1 to 3, 3 to 4 and 4 to 5, we are going to be writing down their cost slopes. 1 to 3 is going to be 100, 3 to 4 is going to be 0 and 4 to 5 is 10. Okay. And now let's go ahead and look at the crashing details for this project. So as you know, 1 to 2 has already reached its maximum limit, right? So we cannot crash this any further. We have already reduced this by 2 units and now it has no more units left in order to decrease, right? This is the maximum. It has reached its limit. However, if you remember, we had the provision of removing 5 units from activity 2 to 5, but we had removed only 4 units due to the limitation. So we still have 1 unit left in that. Okay. And so that's what we are going to be doing. We're going to be crashing the activity 2 to 5 and the activity 4 to 5 by 1 unit. And why are we crashing activity 4 to 5? Because of course it has the least cost slope. We cannot consider 3 to 4 because it's 0. So therefore this value is null. So we are simply going to remove this from our equation. We're not going to consider this. We are only going to compare activity 1 to 3 and 4 to 5. And activity 1 to 3 is higher than 4 to 5. And we are only going to consider the activity with the least cost slope. And since we only have 1 unit left in 2 to 5, we are only going to be reducing activity 4 to 5 by 1 unit, even though we have the options of reducing it more. But we won't be doing that. We'll only be reducing it by 1 unit, because there are 2 things that you have to keep in mind. When you have 2 critical paths, one thing that you have to keep in mind is that you cannot crash an activity of only a single path. You'll have to crash activities. You'll have to crash the activity from both the paths. And secondly, you'll have to make sure that the number of units that you're crashing from one path have to be similar to the number of units that you're crashing from the other path. So since we are crashing only 1 unit from 2 to 5, we'll only be crashing 1 unit from 4 to 5 as well. And that's what it says right here. Now we'll crash 2 to 5 and 4 to 5 by 1 unit. And that will be our third iteration. So in the third iteration, from the first critical path, we have removed 1 unit from activity 2 to 5. And from the second critical path, we have removed 1 unit from activity 4 to 5. Okay, so now activity 2 to 5 has the duration of 5 units and activity 4 to 5 has a duration of 2 units. So now the total cost once again is going to be the direct cost, 580 rupees plus 2 into 50, which was our initial, if you remember right here. Yeah. Right here you had 2 into 50, right? That was the number of units that we had removed, the number of units that we had crashed into the cost slope of 1 to 2. Similarly, we have the cost slope of 4 into 60, which was also done in the second iteration, and then we have 1 into 60, right? So we are reducing the cost we are reducing 1 unit, right? And the cost slope of 2 to 5 is 60. So 1 into 60 and 1 unit from 4 to 5, and the cost slope of 4 to 5 was 10, right? So this is nothing but the total crashing cost, right? Crashing cost. So direct cost plus the crashing cost plus the indirect cost, which is 75 rupees. So 580 plus 2 into 50 plus 4 into 60 plus 1 into 60 plus 1 into 10 plus 75. This gets us to rupees 1065. Now further crashing is not possible. Why is that? because since we already had just one unit left from the first critical path 1 to 2 and 2 to 5, and we've already removed that one unit, now the crashing for both is 0, right? They've the activity 1 to 2 and the activity 2 to 5 have already reached their limits, so there cannot be any further crashing done in this critical path. And since there can be no more crashing done in this critical path, we cannot do any more crashing in the other critical path as well, even though it is still possible to do crashing in the second path, but we cannot do that anymore because it has to be done simultaneously in both the critical paths. Therefore further crashing is not possible, and the optimal project duration is nothing but 11 days. How did we reach 11 days? 1 to 2 and 2 to 5, right? That is 6 plus 5, which is nothing but 11. 1 to 3, 3 to 4 and 4 to 5, which is nothing but 4 plus 5 plus 2, which is once again 11. So this is nothing but the duration of the critical path, the latest duration of the critical path, which is 11 days. And then we have the optimal project cost, which is nothing but 1065 rupees. And I hope this explains the concept.